Okay, this part of the video is probably the shortest part. It's just talking about inscribed quadrilaterals. When you have a circle and you end up having a quadrilateral drawn inside of it, not all quadrilaterals will actually could be inscribed in a circle. A parallelogram, for example, cannot work. But any ones that can work, we call a cyclic quadrilateral. And basically, if you do, the theorem says that the opposite angles are supplementary. And we're going to verify that just with a little measurement. So if you look at, let me just label these angle A, B, C, and D. If I measure angle A, that gets me approximately 103. And if I measure angle C, it looks like I'm at about 75, 76, 77. And if you do a quick add on these angles, these two angles should add to 180. And the same thing will hold true for B and D. If you look at angle B, that's about a 92 degree angle. And so this should be 88 if I want them to add to 180 or close to it. Well, it's about 87, 88 degrees, but you get the idea. So any two angles that are across from each other in a quadrilateral inside of a circle actually are not equal unless you get a square, but they will add to 180 degrees. Okay, so 103 plus 77. And the same thing with the 88 and the 70 and the 92. So we've got a couple problems here I want to tackle with that. Opposite angles are going to be supplementary. So opposite angles are supplementary. Not really a formula so much as a concept, but we use that concept to solve some problems. So let's look at number 19. In the diagram, quadrilateral ABCD is inscribed in circle O. What is the measure of angle DAB? Well, DAB is opposite of the measure of angle DBC. So let's do a little color coding on this. DBC is over here. And I know that angle DBC plus DAB should add to 180. So the measure of angle DCB plus the measure of angle DAB, their sum is 180. And I don't know the measure of angle DCB, but I know part of it. And I can get the other part using what I know about inscribed angles. So if you look at the segment connecting A to C, that's an inscribed angle. That's intersecting arc AD, which is 36. So I can get angle DCA by taking 36 and dividing by 2. Half of 36 is going to be 18. So I got a nice little 18-degree angle. Now I know that these two angles together form angle DCB. So 18 plus 39 is that angle, and that's going to give you, let's see, 49, 59, 57. So if I want to know the measure of angle DAB, I'm going to take away 57 from 180. And 180 minus 50 is 130. Take away another 7, and that should be 123. Angle, or question number 20 is a little bit on the more basic side. See if you can try number 20 on your own. On number 20, it says in the diagram, quadrilateral ABCD is inscribed in circle O. They're giving you the measure of angle A is 54 degrees, and the measure of angle B is 110. Remember that opposite angles in a cyclic quadrilateral are going to be supplementary, so I can get angle C by subtracting 54 from 180. So since opposite angles are congruent, supplementary, I'm going to do 180 minus 54. And the measure of angle C is going to be, 180 minus 50 is 130, minus another 4 is 126. So there's that. And I can get angle D. Those two are supplementary, so the measure of angle D is 180 minus the measure of angle B, and that's going to give me 70 degrees. So that's just a little bit of a subtraction from 180. Question 21 is more of a solving issue, but again, we want to identify the opposite angles. Since opposite angles are supplementary, I'm going to add these two together and set them equal to 180. So that's going to be the same thing with the x's and the y's. So to get x and y and get all the angle measures, we can just solve two equations and plug stuff in. So to get x, I'll do 7x plus 30 plus 3x plus 50 equals 180. Combine your like terms and you're going to get 10x plus 80 equals 180. Take away the 80 and divide by 10. And there's your value of x. And the same holds true for y. You're going to do 2y plus 40 plus 3y equals 180. That's going to give you 5y plus 40 equals 180. Take away the 40, 5y equals 140. And 140 divided by 5 is 28. And once you got x and y, it says what are the measures of all the angles? Plug it in. So the measure of angle A is 7 times 10 plus 30. That's 70 plus 30, which is 100. Since opposite angles are supplementary, you could plug in 10 times 3 is 30 plus 50 is 80, or you could do 100 from 180, and that's going to get you 80 degrees. Same thing with the y's. You can plug in the y into one of them and subtract from 180. So 3 times 28 is, 30, 60, 90, minus 2, minus 2, minus 2, that's 84. And this is going to be 180 minus 84. So that's going to be, 100 minus 4, 96 degrees. And so those are your 4 angle measures. See if you can try this one here. Pause the video and check your answer. Okay, we're setting this one up, and then we'll be done with this section of the video. Oops, I mislabeled that. Hold on. It's 3x minus 12. And this one is going to be 4x minus 25. Now, there's a lot of extra information on this problem, but you have a quadrilateral. And so ultimately, your goal is to get the measure of angle BAD, which is the same as the measure of angle DAB. These are opposite angles. set up your equation. You're doing just the same thing we did over here. So it's going to be 7x minus 37 equals 180. Add the 37, you're going to get 210, 217, and 217 divided by 7 is 31. So x is 31. What's the measure of angle BAD? Three times 31 minus 12. That's 93 minus 12. That should be 81. So the measure of angle BAD is 81 degrees. Cyclic quadrilaterals. That's how you do those. All right, that's the end of that section. Watch the next section for the last two types of angles.